Right. Probably get started here in a couple of minutes, waiting to see if anyone else shows up slightly. Um, but hello. Uh, my name is Hyacinth. Uh, some of you probably know me. I don't know who's here. I don't know who's not. Um, and Today we're going to talk about doing weird text things with computers and code, basically. Um, so got like a little presentation up top just to kind of talk about some of the more theoretical elements of what we're going to be doing, and then we'll get into like kind of practical stuff. I'm not entirely sure because I haven't really timed it out or anything like that how long this is going to take. I'm really bad with time generally. Um, but let's talk a bit about what generative text is, what you can do with it, why you might want to use it, why, like, when maybe you wouldn't want to use it, really quickly. So, if you can and would like to, uh, we would love some money, basically. So like, yeah, I've got like between five and $15. You can Venmo Babycastles, link below. That'd be super cool of you. So, and like, I'm gonna not necessarily assume a ton of programming knowledge. It's gonna get kind of technical at a point, but like, I'm with this kind of stuff, I'm often way more interested in like how we structure our grammars than like the specifics of how we write a recursive function to do the thing or whatever. Um, it's one of those fun and interesting parts of like domains of programming where you there is a very there's a lot of like kind of structural design stuff that goes into it in addition to the kind of nitty-gritty programmery stuff. So let's start talking about this. So gonna focus this thing. So like I said, what I'm planning on doing today is we're gonna talk a little bit about like the theory of generative text and like generators broadly, and then we're gonna get into some specifics about techniques and tools that you can use. Hey Chris, what's going on? And if you have any questions in chat, just like let me know. I'll try to keep an eye on that as best as I can. Hey Nolan, what's going on? And yeah, like I'm gonna like ask for kind of a lot of audience participation, I think, just because like, you know, we're gonna be writing a lot of words, and the words, like, it helps to crowdsource the words that you write sometimes. I wrote this whenever I've done like generators and stuff like that in the past that are text based. I'll just like ask the people around me, like usually my spouse or friends or whatever, like, hey, what are some things that might fall under this category? And I'm gonna be doing that a lot today, I think. So then we're getting into some specifics. Specific techniques and tools that we can use to do this sort of work. Yeah, so I'm recording it, definitely. Slides can be available if you want it. There's not much to the slides. Like, I just, being a teacher, like, my teacher brain works best when I have slides to work off of, just so that and like my ADHD brain, kind of goes off the rails sometimes. So like slides keep me focused. And so there's not like a ton on them, but they're like, various talking points. There are some like, I give some references or some like further reading sorts of things at the end that you might want to have available to you. I'm going to be providing all of that through my talking also, and I'll put the URLs and stuff like that on the screen. But yeah, I could definitely make the slides available, probably as a PDF if that works for y'all. So, and then I'm gonna make like 3 generators today, but there's one main one that I've sort of been thinking about. That's gonna be the most like grammatically complex, but like insofar as the code is concerned, one of the least complex. that we're going to do, and I'll show you how that works. We're going to use like a generative text library basically to do that. And at that point, you can help me make that. I might like put it out in some capacity, or you could just kind of do your own thing and follow along in whatever capacity you feel like. So all right, so what are we talking about? Let's just like get our terminology straight, right? What is generative text? Basically, I'm gonna not go there yet. Generative text is any kind of system that makes words appear that you did not hand author. That's kind of how I like to think about it. A less maybe technical way of describing it is that a lot of the time they work very text generation systems work very similar to like Mad Libs or something like that, where you'll give a framework usually called a grammar, that is like, okay, so we want to make a sentence. What is a sentence? It's a noun and a verb or whatever, and then we can then kind of sub in from big lists of words that we have whatever fits those kind of rules or parameters, right? So like when would we want to use a system like this? The way that I like to use them a lot of the time is really more aesthetic than anything. I think that like variance in the words that you have in your game or whatever just like gives a cool touch to it. Could be games, could be like, you like a ton of Twitter bots use systems similar to this where like, a weird video game idea bot, for instance, that's just one that, I love. It has like, if you watch it for long enough, you'll see the kind of structures and grammars that it builds, the tweets that it makes out of. But also, sometimes there might be like, you have to make 1,000 items in a game that are all kind of vaguely similar insofar as like what they do narratively, what they do mechanically, etc. And you don't want to like name them all by hand. That's an instance in which you might want to use a system like this. It might be like the entire point of the game also. Like, going back to the aesthetic things, I don't know if any of you played Hyacinth, which is this really wild RPG maker, like almost claymation looking RPG. It's something to look at, but there's a lot of kind of procedurally generated poetry in that game. So yeah, there's a bunch of reasons why you would, and but like the thing that I kind of want to hammer home is that it is not necessarily easier than handwriting everything, right? It's different and works better in some situations, doesn't work good in some situations, but like you're still in a lot of cases writing a whole bunch of words. So if you want to make a system that takes a lot of that where you don't have to write a lot of words, this isn't exactly what the sort of system that you would want to use for that. Like you can adapt systems like this to pull from databases that you didn't write yourself. We're not really going to get into that today, but like that's possible, right? But then you need to like write a text scraper and a bunch of other things, like you have to query some other database or something like that. We're mostly today focusing on like just you're going to write a bunch of words and then put them together in some kind of way, right? So whenever you're starting to make a generator of any sort, there's a bunch of like considerations and things like that you are probably going to want to contend with. A lot of this is adapted from this essay that Kate Compton wrote. We're going to be coming back to Kate Compton later, and she wrote this essay called "Do You Want to Build a Generator?" Which is very good. I recommend going and reading it. If you notice that my face is kind of covering covering that a little bit, so don't need to see as much of me. There we go. So yeah, that essay is very good, and a lot of these just kind of directly pull from. It is free. You could just Google Kate Compton. So you want to build a generator, and it is, I think, probably the first thing that you will get. And yeah, she is does a lot of work in procedural generation, procedural text especially. She wrote this library called Tracery, which we're going to be using a bit later. And yeah, so whenever you're building a generative system, here's some things that like you are going to want to think about, because it's really easy to say like, okay, we want to make something, but then like it's worth defining what the thing is and going as deep as you can into understanding the parameters and sort of the framework of what the thing is that you're making. So yeah, first question that you probably want to ask is, what are you making? And so like we could say something like, we're making text, right? But a book is going to be, Chris, you can ask questions whenever you want. The question is whether or not I will see it. Like, if you have a question, let me know. So I guess, do you have a question? So if, what was I saying? Like the parameters of what you might want to be concerned with if you are generating a poem versus like an item, like an item description in a game, or like the name of a planet, or like a plot for a TV episode or something like that. Like those are all going to work very different, right? So there is a bad implementation, or like a incomplete implementation of Tracery for Unity. I don't know of any that are like good. So that's like, I've been in sort of a funk lately. That's something that I kind of like want to do maybe in the next like bit of time, is like make a, not like a good implementation of Tracery or something like that, but like something like that should exist. And I don't know of any, but like there might be some that I'm just blanking on that I don't know about. So the first thing, once we've like kind of defined what the thing is, right, that we want to do is get as specific as we can with the parameters and constraints of the thing that we want to make. So that again is like, what does a good instance of this thing look like? Like, think about like, I'm gonna talk not about text for a moment, but if we think about something like a Spelunky level, right? Derek Yu, the creator of Spelunky, definitely like went through a lot of revision of like what a level needs to have in it. Like at baseline, you have to have a start, you have to have an end, and you have to have a way to get from the start to the end, right? But like then that, like if there's just basically a straight line between the beginning and the end of the level, that's not terribly fun, right? So like this is probably more complex than we need to consider, because we're not dealing with like things that move and stuff like that. But ask yourself, what if this generator is successful, what does it do? Conversely, also, like you want to think about what a bad instance of this thing looks like. So again, like that could be, and like what bad is to you is something that you're gonna have to think about as well. Like, I think that I'm gonna talk about this in a moment, but like variance can be really fun. But like if you want to make a generator that makes like flowers and it starts making like swords or something like that, like that might be interesting, but that's a failure of what the intent was, right? If you and like even that is like better than setting out to make a generator that makes video game levels and have the levels not be completable. My friend Mike Cook wrote a good article on who I'm going to talk about later on, I think. Yeah, like sword flowers, that does sound extremely sick, and that might be something that where like it, you run your generator and something weird happens, and you have to make a call of like, okay, am I cool with this? Do I like that it is making this sort of artifact? And if so, then keep that. If not, figure out what is happening and then take that out. Some of like in text, some of the worst failures that you could do is like when your generator accidentally makes something offensive, right? Especially if it's like a Twitter bot or something. So you want to make sure that like you have a blacklist or a if something does something bad comes out of it in that respect, find out what the grammar did to create that and make sure that it doesn't happen again. Like when I was working on this game, I made this game a while back called Transfer, and we had a procedural name generator. And the way that it worked was it just stuck letters together. It used a similar kind of system then to what we're talking about today, and it just took like, it was like, made a consonant, vowel, consonant, consonant. And like all the names that it made were therefore pronounceable, but some of them looked a little weird. But that form can generate some swear words. It can generate some like racial epithets or things that look enough like that like I didn't want to deal with that. So for that, I checked it against a crowdsourced list of as many different kinds of words as I could that were like bad or that I didn't want my generator making, right? So that when you're dealing with like whole words like what we're doing today, like usually you can see when things like that might happen. Don't put swears in your grammar if that isn't something that you want to do. But when you are generating things like out of letters, for instance, individual constituent parts or whatever, or like phonemes or parts of words or things like that, you might want to consider like, is this making things that I don't want it to make? So that's all to say that like the more that we can constrain in our heads at this point, right, what the thing is, the more accurately we'll be able to describe what we want it to make. So I think that probably makes sense, right? So as we were saying before, though, like another thing that we want to think about is what the outliers are, and do they still function as an example of the kind of artifact we're trying to make? So that's like, I don't know if any of you follow the bot brutal.exe. It's pretty cool. It generates like proc-gen brutalist architecture. And it looks super cool, but sometimes it just makes like, like 17 cubes floating in an endless expanse or something like that, and things like that are like cool and also kind of examples of the thing that it's trying to make. So again, you're going to need to think about where the lines are between like acceptable and unacceptable stuff, right? For our purposes, like we're going to create very structured forms for what the thing is. So there's not going to be like a ton of variance, but there might be some surprises once your grammars and lists and stuff like that get big enough. But yeah, like variance is fun. I think that if you can introduce some amount of variance, it's worth leaning into, especially if like the stakes are pretty low. Like if you're just like, if you're not making like a AAA game with like, real intense procedural level generation, whatever's, yeah, make a thing that pumps out some amount of like some amount of nonsense. I don't know. So let's get into some more like specific theory as to how all this stuff is going to work, and then we'll actually get into some code. So we're going to be working with what are called context-free grammars. And you can like, look up more specifically what that all means, but basically like the way that a context-free grammar works is that we have like what's called a production rule, which is kind of like a symbol that we use to replace other stuff with. And for our purposes, our production rule is going to usually be like a word or a string or something like that refers to a list of other words. So like we could have a rule that's like nouns and have that refer to like 1,000 different nouns or whatever. If we want to get more specific, we could be like, which we usually do, right? We could be like animals. If we want to get more specific than that, we could be like insects or whatever, And again, usually specificity is really good. Excuse me, when we're dealing with systems like this. And we're going to be using some recursive functions or referring to some recursive functions, which is basically, for those of you who don't know, a function that calls itself. It'll become immediately apparent like why we need recursion for this sort of thing. But basically what we want to do is drill down as deep into like this sort of grammar tree as we can. And once we can't go any deeper, put everything that it got into a sentence. So like that's all very kind of theoretical. So like let's talk about like how it all works practically. So like let's say we want to write a sentence using a generative system. We could write like sentence equals NV, where N is a noun and V is a verb, right? Pretty simple. And we can just represent N and V in this case as like again lists of nouns and lists of verbs. But like, and that'll be fine, right? And that's going to be kind of the first approach that we're going to do. I'm going to show you like 3 approaches. 2 of them are kind of the same, but like with different degrees of complexity on both your end and the grammar end. So yeah, like that'll be fine. But like usually we want our generative text systems to be a little bit more complicated than that, because like, we could probably like, this doesn't seem like it gets us that much. Like it might get us some, like it might afford us some amount of like being able to hand off some of the work that we don't want to do to the computer, or like some amount of like interesting variance or whatever. But like where these systems really shine is when you have really like kind of crunchy, complicated grammars and stuff like that, and then you see how it pulls words and fits them together and stuff like that. And like probably skipping over a few levels here, but let's say I wrote a sentence like, today I'm going to alpha. Usually you see like the simplest form that context-free grammars illustrated as like A equals alpha, so I'm using alpha, that's fine. And so alpha can represent like, let's say a list of things that I'm doing. So like it could be either teaching or going somewhere. Today I'm going to teach, or today I'm going to go somewhere. And like from a code perspective, basically what this is doing is like, this is basically an array, and it's our system is going to randomly pull one of them from it. And like if we want to get more complicated with it, we could weight the probability of it pulling from whatever, either like within one pass of it, or like depending on external factors or whatever. But what if we wanted somewhere to not be somewhere and instead be a different symbol that refers to a different list? Like, we could hypothetically do that, right? So like if alpha is teach, then it's just going to return that. But if alpha is go somewhere, maybe we make it like go to the P, and where the P could be mall, park, or basalt temple. I don't know. And so like that's kind of like, you could see sort of like how the recursion would work with this, right? So like we're going to start somewhere and then expand it. That's usually what this is called, like expansion, downward until we get to some kind of terminal point, and then pull all of that information. Code will keep track of where it is, sort of, and then put it into some kind of form that is legible and understandable. So that's probably enough theory for y'all. That took about as much time as I expected it would. So we're going to now describe 3 different though related methods for doing some of this stuff. That's the next thing. So I'm going to stop my localhost, switch over to this, and okay, so I'm gonna pull up my, this is all like blank, so you don't have to worry about, oops, minimize that. I just wanted to get like a scaffold together. Like I said, I'm doing this in P5, but a lot of these techniques will kind of work in whatever you want. The thing with tracery, which we're going to get to eventually, as the last part, is that it is a JavaScript library, so it is easiest to do with JavaScript. There are implementations in other engines and frameworks and stuff like that. Like there's a Twine implementation of it, which I've used quite a bit, which I like a lot. There is, like I said, a kind of unfinished Unity implementation. But so the first thing that we could do is kind of like brute forcing it, right? Let me pull my notes up. And at this point, I'm gonna actually make these like this so that I could see you all. I'm going to just want to get my notes up. Not that. Which one? Where am I? This happens when you teach too many classes and you don't know where they're there we go. All right, so let's say, for instance, we wanted to make, again, like an item name generator or something like that. Give me some, when you want, some like kinds of weapons you might see. Or it doesn't have to be weapons, it could be other kinds of items, equipment that you might get in an RPG or something like that. So while you do that, I'm gonna make an array to hold them. So we're gonna call it item type equals, and again, I'm assuming, so hat would be the thing there. Oh yeah, some fancy boy weapons. Rapier, espé, sword, shotgun, sure. Staff, daff wand. So I'm just like, you know, making a list of different kinds of things. Crystal. Maybe like a pendant or something like that. Yeah, and you can keep going. And like we could, if we wanted to, we could, oh, epay. Is that how you pronounce it? Epay? Yeah. Espe sounds cool and magical also. So like, and we could keep going. And we could divide this out into like, you know, weapon type and armor type if we wanted to do that. But like, this is just demonstration right now, right? And so now let's, a lot of you in chat, yeah, same, Chris. Live programming is pretty rad, I think. I spend like so much of my time doing stuff like this also because I teach like 4 college classes, like college class sessions, 5 sessions a week, maybe. Not anymore, but like a lot of my time is spent in front of a code editor on a stream of some description. So a lot of you were also like giving adjectives and stuff like that. So let's make that a list also. So adjective equals, it's gonna be another array. Hey Krasno, what's going on? We are making a fantasy-ish game item name generator using a kind of really brute force sort of method. So what are some adjectives that we could give to like any of these? And it doesn't have to be like things that we already described, but like, you know, magical is an obvious one. Cute is another one that I saw that I like. All of mine, like for my mysterious, let's go with that. And I'm kind of like rolling with the sort of Diablo-ish format. That's how I'm thinking about this. It's like, you know, the blank of the blank, or like that sort of like structure, right? The doing things like this, which like, again, this most of the time isn't the way that you are going to want to. Exalted, that's a good one. That's not how you spell it. Most of the time when you are making any kind of generative system for a game or whatever, you're not going to want to do it like this, but this is like a quick and dirty way to go about doing it. And like works best when you have a very structured kind of thing that you want to make. God, okay, fine. Got our elite staff, or whatever, of course. But like, you know, this form works. Cursed, also good. Works good for something like this because we have like 3 words and we're just gonna stick them together. God. We could put that next for like the next part. It's like the cursed wand of the gamer. I'm so mad. I have one from my list that I made ahead of time that I like. Honed. Maybe like legendary. Maybe caustic. Yeah, all of mine are like dark and awful. I know, Chris, I will not do that. Fanatical, I like that. Cool. So you can keep on shouting out things. I'm gonna move on to the next section. And then like I call this like modifier. Like this is like your like of the whale or whatever. Of the blood god. I just want to put another one that I like. Radical. Of flame. Cool. Keep shouting things out if you want. Wholesome. No, I refuse, Kresno. The waifu wars left everything as dust. Fine. I could get a few more. Anyone else besides Chris and Kresno in chat? The full moon. From the east, that's good. Get a variance in. There we go. Throwing y'all a bone. That. So yeah, so we got this, and we, like I said, we just got like some lists of some of the ancients. I like that. So now we're those of you who've I assume that most, if not all of you, have used p5 before, but p5 has like a couple, you know, callback functions as you might expect in any kind of framework that works like kind of vaguely modern game engines or whatever. It has a setup function and a draw function and etc. We're just going to be basically using the setup function today because we don't need to do anything over time for the most part. We're just going to you know, basically write a paragraph element to the screen on startup, and then we could just refresh to get a new thing or whatever. We could make that a button if we wanted to, but you know, I'm not. So got a setup function, and then like to generate no, p5 is it's basically like processing, but JavaScript is kind of the way that you can think about it. It literally came out of processing and the processing foundation. So it's designed to be kind of accessible, approachable to artists and people who aren't like who aren't software developers or like web developers or whatever. But as a result, it like, you know, I know a lot of web devs and JavaScript devs that don't really love it because it's like works way different than normal JavaScript because it kind of imposes a draw loop into the browser that the browser kind of already is doing. Whatever. It's cool for this kind of stuff. And like, I don't know, I like it. I think that it works well to illustrate sort of this thing that we're talking about today. So we're just going to make a new variable. We call it item name. And then, so p5 has this really neat feature that we're going to be using a lot, where we can use the random function. It's a programming framework. It has a random function, but we could basically just pass an array directly into it. So rather than saying like you know, modifier then like random dot range, like whatever, we can as you might with like a different language, we could just say, what's our first one called? Adjective, right? We just say random adjective. Then plus space plus random item type plus space plus random modifier, which I find really cool. Oops, I should probably think that these should all have semicolons after them also. Like, JavaScript's weird in that it won't throw an error if that happens, but it likes it more if you do, I think. And then we're just going to, we could just debug this out of the screen, but I'm going to create p and then and someone got mad. Oops. I put that to a different project. Sorry about that. Okay. So there we go. So if you know, for those of you who've never used p5 before, like you need an index page because it's, you know, it's a JavaScript thing, so it's looking for a reference to the p5 library, which I just got right here in it. So it's just like script source p5.js, and then this is the thing that we just made. So so yeah, let's hope that this runs. There. So yeah, got a curse wand of flame, got a magical wand of flame, got a heretical rapier of the waifu wars. Sure. So then we can like get a little fun with it. Magical staff of the blood god. So then we could get like a little more creative with it. Where like, to me anyway, the ones with these modifiers on them seem rarer than, you know, the other stuff. So what we could do is we could just set up like a little probability thing that's like, if I don't know, random 1 to 10 less than or equal to 2, let's say, then it's going to do that. I've been using too much Lua, so I want to be typing in Lua, but then we could just do this without that last bit. I'm not doing color, just because I don't want it. But you could do whatever you want. Like, a cool thing about a lot of this stuff is that, like, yeah, we could assign like a rarity value to it or whatever, you know, we could represent that some other way. Like, I just don't want to mess with the color right now. So now, most of the time it will be will not have a modifier at the end of it, but occasionally it will. If it doesn't do it in a few more clicks, I'm just gonna move on, because trust me, it does. But probability is weird sometimes. You get it. So, and then we could, like, you know, do that with the, like, we could make different sets of adjectives or whatever that are, you know, more weighted for different probabilities or whatever. But yeah, so like that is a way to kind of brute force a lot of this. And again, this kind of way of dealing with this is best when you have a very tightly structured form of whatever you want to generate. I'm going to tell a story because the last time, or not last time, a really old game I made was this game called What End. And it used a generative text system that was basically similar to this. It was one of the most nightmarish pieces of code that I ever wrote because it was like before I knew really anything about how any of this stuff works. So I, you know, tried to use like this really brute forcing method. And so let me see if I could get to my GitHub and show y'all. No, GitHub doesn't want to let me into my GitHub right now. I'm not going to go through that on stream. But basically what I was generating was like kind of an epilogue. It was almost structured kind of like an epitaph for the player character, or like, you know, just sort of like you seeing a weird premonition when you go home, when you start walking home or whatever. Excuse me. And so I had all of these lists that like interlocked in weird ways and looked for weird flags in my code and stuff like that. And my script ended up being yeah, kind of like at the end of the Fallout games, except like made in 3 months with zero budget. It's a fine game. Y'all can go play it. It might be on my itch.io page. Yeah, promo my own stuff. Nil.itch.io. Yeah, it's this one. Very old game, but yeah, it the script to do all of that ended up being like 1900 lines long. It was a nightmare, and I do not advise y'all doing that. Cool. So that's like method one that we're going to discuss. It's fine. Does what we needed to if we wanted to do something like this. Method two is where things get a little bit more sophisticated. And it's when we are actually going to start writing some recursive stuff to deal with kind of going different layers into it. And let's hope things don't break. What's this one? So, pull up my notes. So we're gonna have, sorry, my messages didn't update. Yeah, cool. They did. It just my chat rolled back for some reason. All right, so we're gonna start this off kind of the same way. We're going to create a variable that's instead of writing a bunch of arrays though, I mean, we're still going to write a bunch of arrays, but we're going to write a bunch of nested arrays kind of. And this is going to be like, it's going to get a little messy. And there are inevitably better ways to go about doing this. This is the way that I know, so whoops, var rules. So here is where we're going to write our production rules, and it's going to look basically like a JSON object. Like also another thing that you could do, and something that like tracery and other, generative text like libraries and stuff like that allow for is importing JSON objects, importing other files. You could, if we were interested in like text parsing today and stuff like that, we could write our own text parser to go through, do like a recursive descent algorithm to pull out like text and split it in the ways that we want to. But this is simple enough and easy enough to understand. So we'll just do this. So I think for this one, I want to make a, I was thinking like I don't know what this looks like exactly, but like a monster generator, because I like monsters. So we're going to come back to what this actually like looks like though in a moment, because I want to start just like writing the code that's going to deal with it first. So we're going to start with our setup function, and not need a canvas because we're just going to print text to the screen again. And I'm going to make a thing called origin. That's where we start, right? So like if we have any kind of like tree that we're going through, we always have like some kind of root node, and that's what our origin is. And since it's a monster, I think I'm gonna call it M for short. So up here, I'm gonna write M colon. If any of you have not used JSON before or written JavaScript objects, it's like pretty simple. They look a lot like arrays, but so basically what we're going to have is another thing, basically the kind of grammar structure that is going to be encapsulated by this. So like we could write like, should have actually written something for this, but I didn't. So we're gonna roll with it. Anyways, this is like the thing that's gonna print is gonna go in here. But we can also like write symbols and stuff like that in this array that will refer to other symbols that we'll use later. That will refer to other arrays basically that we'll use later, I meant to say. So got origin M, expansion. How are we doing in chat? Am I making sense? I got like 4 hours of sleep last night also, so if I'm not making sense, let me know, please. So expansion is just going to be an empty array, and this is what we're going to like basically populate with our stuff. And we're going to write a function, so into a variable called result. Oops. That's going to be called expand. And I'm going to actually write that up here. So it's a start node, and then so basically what we're doing is we're going to, every time we run this expand function, we're going to be passing it the node that it's starting at and then the expansion array. So basically like it's going to start, like going back to that diagram that I showed up at the top, it's going to start at a node, look into it as deep as it can, find if there's anything else that refers to something else, and then run it again, basically. Hope that makes sense. If it doesn't, let me know. So we want to pass it the origin, which is our node M, and then our expansion array. and then just log it out. Did that in my notes when I was figuring this out, but all right, so now let's actually write the meat of it. So if rules. So we're basically like looking for if this thing exists. So, sorry. If rules start, we're going to pick a random rule inside of the node that we're looking in. So again, we're looking at this thing. When we expand it, we're going to pick a random thing inside of that array, basically. And then we're going to loop through it. Less than pick.length. So then we basically run expand on the next node. Otherwise, we're going to stick the stuff that we just got onto the end of that array that we just made. And then we're going to return. Oops. We're going to join each by a space. Now this is like, it's not necessarily going to get hairy here, but like this requires that our thing takes certain forms, right? We need spaces between each word that we have, basically. And so let's actually go and write some rules. So again, I think that we're making a monster generator because I want to. I don't know. It's my class. So like where the, and then let's because we already used M. So, and for name, oops. So this is going to be another array. And each one of these is going to be arrays also. Oh, I messed this up a little bit. So for this, we want each one of these to be different strings so that we can look at them individually when we're running them through. So it's always going to start with beware, I guess beware of the, and then whatever the thing is. So give me some monster names. I don't know. All right, so my brain just exploded, and like, you know, bugbears are a thing, right? my brain said bear bug instead, so that's what the first one's gonna be. And we could, like, if we wanted to, we could also, like, you know, have this be a generative symbol also, where like we have like different pieces and then we stick those together. But like, I just want to see if this works, and then we could get more complicated with it. But yeah, give me some more monster things, monster names, I guess. My brain just keeps on exploding and giving me the most ridiculous things. So, flame snort. It's another. There we go. Wolf bear. Good. What part is wolf and what part is bear, or none? Is it a smoke screen? Mistwalker. Nah, that's that. Realize that that's that thing from that bad old video game. Old game I made is called Dust Ghost, so I'm gonna do that. Whatever. We don't need a ton. So I'm just gonna see if this works, and then we could add some more complexity to it. There's a good chance I messed something up. So again, gotta pull our p5 library, and then whatever you named your file with all this code in it. Save that. Save this. Yep. So beware of the flame snort. Beware of the bear bug. Cool. So now let's get a little bit more complicated with it. So I'm going to just, this is me kind of like hacking it a little bit because of the limitations of the way that we're doing this right now. But like if I said, for instance, period, right? That would put a space between it. I don't want that. So I'm just going to put a period at the end of each of these. Then like so if rules start is referring to this, right? So whatever node we're passing it in the like as our first argument, basically, that's going to this, and it's just checking to see if there's a start node. So if there's a start node, we're good, and it runs through the rest of it. Otherwise, it just takes everything and sticks it at the end of the array. Does that make sense? So it has we already used n. So here, this is where we're calling it initially, right? So whatever this is, whatever this returns gets put in a result, and whatever we called origin. So here origin is m is this, so or m gets passed to this, whatever's in there, and then like it will keep going through the tree until it reaches a point in which it can't anymore. That makes sense? Cool. So it has what's a good, we already used n. We could say like num for number. Because I think we can. That's wrong. It has to be a string. 16. 46. I'm just writing numbers. It also makes sense to do it as words, but I'm not doing that. Because 7. 5. 24. That's not a string. All this has to be strings. And then gotta remember that these all have to be different. Than B. So it has an inordinate amount of a certain kind of body part is what I'm going for. So give me some body parts that critters that lurk in the woods can have. So it has to be an array. Eyes. Good, obvious one. Legs. Another good, obvious one. So I've been playing Dark Souls a lot. Wings, cool. Killer. Love a thing with way too many wings. Claws. Want to say mouths. Sure. Tongues. I've been playing Dark Souls a lot recently, and mimics in that game are so tall and so leggy. What the heck? I'm blanking. Horns. Antlers. Tusks. So now we got cool. But where the bear dog has 5 horns. Probably would look better if we made this a word instead of a number, but that's fine. And then we could say like and then we could just do that again, or we could make a different list so that it doesn't overlap. Right now we're not like pulling things out of the list, we're just like checking it. So it could just generate the same thing twice, but whatever, we're learning. Num B. Yeah, so it's 5 claws and 7 claws. Oh, right. Because we are getting this, it's always going to be the same. So let's make another list. Let's just duplicate this and into just call it J. I don't know. Could change those also so that they're different. Like maybe we get these out of here. You could be cleverer than this, but don't want to. Okay. Oop. J. It's a whole lot of body you got there. So yeah, got a critter maker, and you can see how this can go like really wild. We can then start like, and what we're gonna do next is going to like say like, okay, so what if some of these are also grammatic symbols, right? So like we could take like something in B and point it to another list, right? And I find that like, you know, it gets really unwieldy if you're doing that like this. Like you can, and like, you know, if we're doing this more for real, then we'd want to tighten up sort of how we're doing a lot of this stuff, but we're not. Another thing that like we could also